the launch of India's first solar mission Aditya L1. This mission will study the sun from a unique perspective and reveal some of its secrets and mysteries. But before we get into the details of the mission, let me ask you a question. Do you know how AI is involved in this mission? What are the mission objectives of Aditya L1? These are some of the questions that I'm going to answer in this video. So, sit back, relax, and enjoy the video.
Aditya L1 is India's first solar mission that aims to study the sun's corona, photosphere, chromosphere, and solar wind. The mission was successfully launched on September 2, 2023, using a Polar Satellite Launch Vehicle, PSLV, from Sriharikota. The mission will orbit around the Sun-Earth Lagrangian point 1, L1, which is about 1.5 million kilometers from the Earth, and provide continuous observations of the Sun for at least 5 years.
The history of the Aditya L1 mission dates back to 2008, when it was conceived by the Indian Space Research Organisation ISRO as a small satellite that would observe the Sun's corona, which is the outermost layer of its atmosphere.
The corona is very hot and bright, and it emits powerful bursts of radiation and particles that can affect the Earth's magnetic field, communication systems, satellites, and power grids. These phenomena are collectively known as space weather, and they can have serious implications for our society and technology.
However, over the years, the scope of the mission expanded to include more scientific objectives and instruments. The mission now aims to study not only the corona, but also the photosphere, which is the visible surface of the sun, the chromosphere, which is the layer above the photosphere, and the solar wind, which is the stream of charged particles that flows from the sun. The mission will also investigate how the sun influences the Earth and the solar system.
The mission objectives of Aditya L1 are:
to understand the origin and evolution of the solar system,
to understand the heating mechanism of the corona,
to understand the acceleration mechanism of the solar wind,
to understand the generation and propagation of solar flares and coronal mass ejections,
to understand the impact of solar activity on Earth's magnetosphere and climate,
to develop early warning systems for space weather events,
to explore potential ways to harness solar energy.
To achieve these goals, the mission will carry 7 scientific payloads, each with a specific function and purpose. These payloads are:
the Visible Emission Line Coronagraph, VELC, which will capture high-resolution images of the corona in different wavelengths and measure its magnetic field, temperature, density, and velocity.
The Solar Ultraviolet Imaging Telescope, SUIT, which will observe the photosphere and chromosphere in ultraviolet light and monitor their variations.
The Plasma Analyzer Package for Aditya Papa, which will measure the properties of the solar wind particles near the spacecraft.
The Solar Low Energy X-ray Spectrometer, SOLEXS, which will detect low-energy X-rays from solar flares and coronal mass ejections.
The High Energy L1 Orbiting X-ray Spectrometer, HEL1OS, which will detect high-energy X-rays from solar flares and coronal mass ejections.
The Magnetometer, MAG, which will measure the local magnetic field around the spacecraft.
The Radio Occultation Experiment, ROE, which will use radio signals to study the ionosphere of the Earth.
Now that you know what these payloads are and what they do, let me tell you how AI comes into play. As you can imagine, these payloads will generate a huge amount of data every day. According to ISRO's estimates, the mission will produce about 1.5 terabytes of data per day, which is equivalent to about 375 DVDs or 3,000 CDs. That's a lot of data to process, store, transmit, and analyze.
This is where AI can help. AI can help us handle this massive data in various ways.
AI can help us compress the data so that it can be transmitted faster and more efficiently from the spacecraft to the ground stations.
AI can help us filter out noise and errors from the data so that it can be more accurate and reliable.
AI can help us classify and label the data so that it can be more organized and accessible.
AI can help us extract useful information and insights from the data so that it can be more meaningful and valuable.
AI can help us visualize and present the data so that it can be more understandable and appealing.
In other words, AI can help us make sense of this data and turn it into knowledge.
The government of India has been very supportive and encouraging of the Aditya L1 mission and its objectives. The government has provided adequate funding, resources, infrastructure, policies, and incentives for the mission. The government has also recognized the importance and potential of AI for the mission and has promoted its development and application.
ISRO has been the driving force behind the Aditya L1 mission, and its success. ISRO has shown a clear vision and leadership for the mission and its goals. ISRO has also fostered a culture of innovation, excellence, collaboration, and openness for the mission. ISRO has also leveraged its expertise and experience in space science and technology for the mission.
The institutes that have been involved in the Aditya L1 mission have shown a great interest and enthusiasm for the mission and its challenges. The institutes have also demonstrated their capabilities and competencies in various fields related to the mission, such as solar physics, space engineering, data science, AI, etc. The institutes have also sought to learn from each other and share their knowledge and skills for the mission.
There have been various platforms and networks that have enabled and facilitated the involvement and collaboration of the institutes for the Aditya L1 mission. Some of these platforms and networks are the Aditya Science Team, which is a group of scientists from different institutes who work on various aspects of the mission, the Aditya Data Center, which is a facility that stores, processes, and distributes the data from the mission.
The Aditya User Forum, which is a platform that allows users to access and use the data from the mission, the Aditya Outreach Program, which is a program that aims to disseminate and popularize the mission and its findings to the public, and the Aditya Consortium, which is a network of institutes that collaborate and coordinate for the mission.
But what are the impacts of the mission?
The scientific impact. The Aditya L1 mission will have a significant scientific impact on our understanding of the Sun and its influence on the Earth and the solar system. The mission will address some of the outstanding questions and challenges in solar physics, such as how the corona is heated to millions of degrees, how the solar wind is accelerated, how the solar flares and coronal mass ejections are generated,
and how they affect the Earth's magnetosphere and climate. The mission will also provide new and unprecedented data on the Sun's dynamics and variability. The mission will also contribute to the global efforts to study the Sun and its phenomena, such as NASA's Parker Solar Probe and ESA's Solar Orbiter.
The technological impact. The Aditya L1 mission will have a significant technological impact on our capabilities and innovations in space science and technology. The mission will demonstrate India's prowess and leadership in designing, developing, launching, operating, and managing a complex and challenging space mission.
The mission will also showcase India's expertise and excellence in various fields related to the mission, such as solar physics, space engineering, data science, AI, etc. The mission will also inspire and motivate more people to pursue careers and education in space science and technology.
The societal impact. The Aditya L1 mission will have a significant societal impact on our awareness and appreciation of the Sun and its importance for our life and civilization. The mission will educate and inform us about the Sun's role in shaping our environment, climate, culture, history, and future.
The mission will also alert us about the potential threats and risks posed by space weather events that can disrupt our communication systems, satellites, power grids, etc. The mission will also encourage us to explore more ways to harness solar energy for our needs.
These are some of the impacts, benefits, and outcomes of the Aditya L1 mission. These impacts, benefits, and outcomes will also enhance India's position and reputation in the world.
So, this is how AI is involved in India's first solar mission Aditya L1. This is how AI is helping us study the Sun from a unique perspective and reveal some of its secrets and mysteries. This is how AI is making this mission possible and successful.
I hope you enjoyed this video and learned something new. If you did, please like, comment, share, and subscribe to my channel for more videos on AI and space science. Thank you for watching.